Hello students, welcome to the next lecture series of Basic Electrical Engineering. Today we are going to start the module 5. Okay, so this is the last module we have in the Basic Electrical Engineering. So what is this module? Actually it is dealing with the alternators. Okay, first part we will have the alternators, then we have the induction motors. These are the two parts we will have in case of the module 5. So in the fourth module we have seen what is the DC generator, okay, and motor. In this module 5 we are going to see what is the AC generator. First one is AC generator and the second one is AC motor. So here we will see what is the difference between the alternator and the induction motor and the DC generator and the DC motor. So if you observe in case of DC generator and DC motor, so we require a commutator. Definitely we require a commutator, because there we are getting the AC output that can be converted as DC, that is done by the commutator we have seen. But in case of AC generator or AC motor, commutator is absent here, because no need of the commutator, absence of commutator is present here. So that is the constructional wise basic difference between the DC generator, DC motor and AC generator and AC motor. We don't have the commutator in this type of AC machines. Next we will see working principle. So what is the difference here? Working principle between the DC generator and the DC motor. So if you observe what is the basic difference, there you have seen field is stationary there, okay, field is stationary, we have kept, conductors are rotating, okay, conductors are rotating here, field is stationary, conductors are rotating. But in case of this is in the case of what? DC machines, okay, that is what. But when you come for the AC machines, so what it is doing is working principle. Here we are trying to rotate the field, okay, so field is rotating, exactly opposite we are doing here, conductors are stationary. So like this we are going to generate, conductors are stationary here, we are going to generate EMF will be induced. So that means the field is rotating, so this rotating field can be placed on the rotor, okay, and here stationary will be placed on the stator. So these are the two parts, and this is the constructional wise we have seen commutator is not there, and working principle, this is the basic difference. Here field is stationary, conductors are rotating, here field is rotating, conductors are stationary. This is the basic difference between DC machines and AC machines, working wise. Next we will see what is the alternator, okay. So alternator, actually how the name it is given, alternator is because it is producing alternating voltage as the output, alternating voltage as the output here. So it is produced alternating voltage as the output, that's why we are called as alternating voltage. And it is called as the synchronous machine also, it is called as the synchronous generator also. Why it is called as the synchronous generator is because it is rotating at synchronous speed. We will see what is the synchronous speed, rotating at synchronous speed, that's why it is called as the synchronous generator, okay. And basic principle we have seen already in case of a generator, DC generator or AC generator. So if you take this as the generator, what is the input we have to give for the generator? We have to give the mechanical energy as the input, and we are taking the electrical energy as the output. This is common, okay. So synchronous speed will be given as ns is equals to 120 F by P. 120 F by P. So it is called as the synchronous generator, and it is also converting same mechanical energy into electrical energy. So you are giving the input mechanical energy by the turbines, and you are going to get 3-phase output. Okay. So this is in the case of AC generator, and this is also works on the principle of Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction. Okay, so that is the difference between electromagnetic induction. It is going to working on the principle of electromagnetic induction, Faraday's laws. So EMF can be generated either in this fashion or in this fashion. So in this fashion we are going to generate how. So field is rotating here, conductors are stationary. So in this way we are going to generate, and here what are the two parts will be there when you see the construction. The DC machines are having, one is field system which is having with stationary poles, north pole and south pole. There the field line is traveling from north pole to south pole. There we are rotating the armature. Here stator is carrying the conductors. Stator is carrying the conductors, whereas rotor is carrying the field winding. Rotor is carrying the field winding. So we are placing the field winding is placed on the rotor here. So there we are placed the field winding on the armature there in case of DC. Here we are placing the rotor field winding on the rotor. Okay, that is the basic difference. So whenever rotor is having the field winding, it is getting excited by a DC source, so that the field will be generated, and it is rotated by the some external source. That external source may be something. It is going to rotate, the mechanical input is given by the turbine, so that you are going to get the electrical energy. This is the basic differences between the AC generator and DC generator, DC motor and AC motor. All these are all the basic difference. And one more important factor is the same machine. Okay, same machine can be used as either generator or motor here also. So the same machine can be used as either generator or motor, as we are discussed in case of DC generator also. The same construction here we can use for either generator or motor. Next we will see. So now we are seeing, we are taking that what we are doing here, we are placing the stationary. So we will see stationary armature. Now we are keeping the stationary armature. Let us see what are the advantages by keeping the stationary armature. That is, we are keeping stationary armature means conductors are stationary here. What are the advantages we will see by keeping the stationary stationary armature. First advantage is power required. Okay, so power required for field is less. Power required for the field is less. So as power required is less means, what will happen is size will be decreases for the field system. As the size will be decreases, inertia also will be decreases. So this is the first advantage. As the power required for the field is less, size is reduced, because of that inertia is also reduced. Second advantage, as size is reduced, so we are already discussed in the size will be reduced. So as the size is reduced, so inertia will be reduced. Because of that, rotor can rotate. Okay, so rotor can rotate at higher speed, which is the main advantage with the AC generator. Rotor can rotate at higher speed, so that you have the high power output. So that is the one advantage, high power output. This is the another advantage. And one more thing, So as you are giving the input through the slip rings, okay, only 2 slip rings are required, 2 slip rings are required. So as the 2 slip rings are required, here what we can say, losses will be decreases, so that what will happen, efficiency will be improved. So that is one other advantage. Next, the voltage rating, okay, so voltage rating of the field, voltage rating is reduced means voltage rating of field is decreased means what will happen. So insulation means the cover what we are providing on the wire, so insulation will be decreases. As the insulation is decreases, the size will be decreases. So this is the another advantage. And so it is easier to insulate the stationary armature for higher voltages, that is another advantage. Next we will see what is the another advantage. No centrifugal force on stationary, armature, that is another advantage, because there is no rotation. Cooling is easy, you can provide cooling can be provided very easily because of the stationary armature. Next, another advantage is stationary can be directly connected to load. Stationary armature, okay, armature output, okay, that is only we are taking from the armature, only we are taking the output. Stationary armature can be, we can take directly load will be connected here. So directly we can connect the load without any slip rings or whatever it may be. So what is happens, losses will be decreases. This is the main advantages of the stationary armature. That's why we are going for the stationary armature in case of AC generators or synchronous generators. So here if you see the construction, of the if you see the construction of the motor, so what how they will be. So you have one stationary frame will be like this, okay, inside you will have the rotor, so the rotor will be also like this. So rotor is getting excited, okay, it is having the field winding like this, so it is having the field winding. Next, stationary is having, let us take the stationary is having a 2 frame like this. Inside the stator, this is called as the stator, okay. So in the stator it is having the stator slots like this, it is having the stator slots, and from that only we are taking the finally output. This is the 3-phase power output, 3-phase power output is available here. Next, so here field is produced, the field winding here we are connecting here. So this can be connected to a DC supply here. So whenever give the DC supply, these conductors are stationary, what is happening is this field is rotating like this, the field is rotating, so that what will happen, the conductor cutting action is taking place here, EMF will be induced in the conductors. That is the basic principle. As we are taking directly the 3-phase output, there is no requirement of the slip rings to the load, that's why the losses will be reduced. That is the basic. Stator is placed, conductors are placed in the stator, field winding is placed on the rotor. So this is called field winding, okay, field winding. And main, this part is this entire part we can call it as the rotor. So rotor is rotating, stator is stationary, DC supply is given for the field winding, so that you will have the field is generated and it is rotated by some external source. So then it is a cutting action is taking place here. Like this the synchronous generator or alternator will works. Okay, so that is the basic idea how it is going to work. Now we will see what is the frequency of, okay, what is the frequency and speed. What is the frequency and speed of alternator? What is the frequency and speed of alternator? See here, for this I am taking some terminology. Here I am taking it as rotor speed capital N, that is equals to rotor speed in RPM, rotor speed in RPM. Next, P is the number of poles, P is the number of poles. Next, F is the frequency of, F is the frequency of EMF in hertz. So like this we have. So whenever you have a pair of poles, let us consider a pair of poles I am taking here. So if we have the pair of poles like this, let us take, this is the north pole and this is the south pole, like this we will have. So this is the north pole and the south pole. So we are rotating the conductor, we are rotating the conductors. So now I am placing the like this. So we are rotating the conductors, or sorry, we are keeping the stationary. What is happening? So if you want to cover, whenever it is rotating, for example, whenever it is rotating like this, so in the clockwise or anti-clockwise or whatever it may be, so how much of EMF will be induced in completion? So for completing of, here you can observe, for completing of one cycle, for completing of one cycle of EMF, so it has to cover how many number of poles here? 2 poles. If it is a 2 pole alternator. So that means what is cycle we will call it as? This is called as the one cycle. For completion of one cycle, let us consider under the north pole it is having the maximum EMF, under the south pole it is negative maximum we have. For completion of one cycle, how many poles it has to cover? 2 poles, right? Next, take another diagram here. We will take the another diagram. So let us consider I am increasing the number of poles here. So let us increase the number of poles like this. Just I am considering the 4 pole generator. If you have 4 pole generator, so here you have the conductor, okay, one is north pole, south pole and south pole. So the conductors are placed here. So this has to rotate once again, whatever it may be. So what is happening here? So to cover, to generate, okay, to generate one cycle of induced EMF, it has to cover. So you see this part. So like this, if we divide, so under the north pole it is having maximum like this, that is first north pole. Let us give the names. It is 1 and this is 1 only, this is the 2 and 2 dash, this is 1 and 1 dash. Under the north pole it is having 1. Next, under the south pole we are having this minimum value, that is negative maximum, that is at 1 dash pole. Next, for one complete cycle we are completed. Next cycle is, that is a north pole. Under the north pole we are having once again the 2. Next it is having maximum. Next, under the south pole we are having the negative maximum, that is 2 dash. So that means how many poles it has to cover? So this is one cycle. Next is another cycle, that means total 1 cycle. So 1 plus 1, how many cycles it is covered? 2 cycles. So for production of 2 cycles, how many poles it has to cover? 1, 1 dash, 2 and 2 dash. That means 4 poles has to cover. So that is what we can write it as. So for number of cycles, we can write as number of cycles can be generalized like this, is equals to number of cycles per revolution. One revolution is equals to, we can generalize it as P by 2. I can say here for completion of one cycle I can take it as 4 by 2, that means 2 cycles we got finally here. So we can generalize as number of cycles per revolution is P by 2, and number of revolutions per second is equals to N by 60. This we are already taken in case of the generator or motor also, how we got in the EMF equation you can observe. So number of, what we can say, number of cycles per second. What is this? Number of cycles per second, we can call it as the frequency here. So cycles, I am writing like this, cycles per revolution into revolutions per second, we can write like this, revolution will get cancelled. Cycles per revolution, we got it as p by 2, and number of revolutions per second is n by 60. So we can write as frequency will be p into n divided by 120. This is the frequency formula of the alternator. This is the frequency formula of alternator. And the speed what it is rotating here, that is called as the synchronous speed. Synchronous speed will be, that is 120 f by p. Very important formula. These two are very important. That is frequency is equals to ns is equals to 120 f by p. So this is called synchronous speed. Because of that only the generator will be called as the synchronous generator. Here p is the number of poles, okay, and ns is the synchronous speed, f is the frequency in the hertz. That's all in this video. In the next video we will see what is the constructional details of synchronous generator and the EMF equation of the alternator. If you are seeing first time this channel, please like, share and subscribe the channel, which is very useful for your friends who are preparing for the external examination. If you have any queries, you can comment in